Okay, going back to factoring quadratics, there were two methods we learned for factoring x squared plus 5x plus 6. One method was basically find two numbers which when added give you 5 and when multiplied give you 6. Right, so 6, you get a product of 6 from 1, 6, 2, 3, negative 2, negative 3, negative 1, negative 6. Where you add them up, this is 7, this is 5, this is negative 5, and this is negative 7. So this is the one we are looking for, and then we split the middle term, and I'm skipping a step here, but you end up with x plus 2 and x plus 3. So we achieve our goal of changing sum of bunch of things into products of things. And now y product, again, this is something we discussed before. Let's say if we want to know when x squared plus 5x plus 6 equals 0, meaning for what value of x does this equation become 0, it's not easy to solve when it's an addition problem. But when it becomes a multiplication problem, it becomes easy to solve because the product of two things can be 0 only if one of them is 0. So it's either this is 0 or this is 0, giving me that either x is negative 2 or x is negative 3. Now a second method we learned was using areas or diagrams, right? So I said in that particular method, x squared is the area of a square x by x. 5x would be 5 such areas which are x by 1s. 4, 5. And 6 would be 6 small things which are 1 by 1. And then what we ended up doing there is we are trying to take all of these pieces and make a rectangle. And we do that by stacking 2 of these thin rectangles here and 3 of them here, which gives me exactly 6 spots to make a complete rectangle using all the pieces. And I notice that this length is x plus 2, and I notice that this length is x plus 3. Now because we are not cutting or removing any piece, the area has to be the same. So this area is the length of the rectangle times the height of the rectangle, which gives me the factored form. Now this method is good enough, but not for all particular cases. So we need to look for a more standard method that works for all scenarios. Again, there's a bunch of ways in which this can be done. Let's see how we can modify this area method to work with any example. Now there is another way in which I can factor this particular equation. What I'm going to do is I'm going to recall this particular observation: a squared minus b squared is a plus b, a minus b. Now the observation here is that the difference of squares can be written as a product. And in previous videos I've shown you how this can be done graphically, or sorry, not graphically, but using the area concept. Right? I take an a by a square, and from it I cut out a b by b square, so that this is my remaining area. Now my goal is to take this L-shaped area and convert it into a rectangle. So what I do is I cut it right over here. So I have two pieces. The top rectangle here, now if this entire length is a and this length is b, then what I'm left with here is a minus b. But this top part is still a. And I have this other smaller rectangle which has a height of b, and if you look at this length, This is again a minus b. So I have two rectangles which have one of the same dimensions, which means I can stack them. Yeah, so I turn this around 90 degrees and I stack it with it. Then I have a, b, and a minus b. Now this whole thing is now a rectangle, and its area is a minus b, and this length becomes a plus b. So this helps me understand that if I have a difference of squares, I can make it into a product. Okay. Now we are going to combine these two ideas to come up with a new method of solving a quadratic equation, or factoring, so which is essentially the step you take before you solve it. We're going to combine these ideas to get a new method in the next video.